Good morning, Pre-Cal. I am interrupting my trash TV to bring you another video. Actually, I'm not really watching it. I have it on mute, but I just like to feel like I'm teaching somebody, so it's there so I can see people. But I would definitely not recommend watching this Steve Wilkos show. It's just trash. But it's kind of funny to watch while it's in mute, all the yelling, not that you can hear it, but then the angry people. It's definitely interesting. Okay, so yesterday we did double angle formulas, and today we are going to do half angle formulas. I know it's a lot of formulas, and all I can tell you is you just got to learn them. I don't have any fun little mnemonics for these. So let's look. We have sine of u over 2, because it's a half angle formula, so it's taking whatever u is and it's cutting it in half, and it's going to be plus or minus the square root of 1 minus cosine u over 2. The cosine half angle formula is almost identical to the sine half angle formula, the difference being that this one has a plus sign instead of a minus sign. And then there are two tangent half angle formulas, as you can see. I will also say this, and we saw this when we did the double angle formulas. If you already have the sine half angle formula completed and the cosine half angle formula completed, and let's say you need to find the tangent one, then you can take your answer for this and divide it by your answer for that, because we know that tangent is sine over cosine. So just kind of throwing that out there. If you already have the other two, there's no point in doing extra work here with a formula. Just do your sine answer divided by your cosine answer. Now, important to note, it says the choice of plus or minus depends on the quadrant in which u over 2 lies. So in other words, let's suppose that u over 2, let's just say that it was 130, and we were trying to find cosine of that. Well, we know that 130 is in quadrant 2, and cosine is negative in quadrant 2. So the answer would require a negative sign instead of a positive sign. So it just depends on where your u over 2 is, and we'll kind of look at that and see how that works. So let's start with example 1. We want to find sine of 22.5 degrees. How can we get 22.5 degrees? Well, if you take 45 and chop it in half, you now have 22.5 degrees. So this 45 that I've written right here, that is going to represent the u. Okay, so we're going to our sine formula. All right, first let's talk about the u over 2, 45 over 2, which is 22.5. Where is that? Well, that's in quadrant 1. Everything is positive in quadrant 1. So right now we're just going to not worry about that plus or minus sign, and we're going to go with just it being positive because it is in quadrant 1. We're going to use the sine formula, so we see that right up here. So we're going to do 1 minus cosine of u. Remember we said u is 45. So it's not the 22.5, it's just whatever number is being divided by 2. That's the number that you're going to be using in your formula. And then we're putting that over 2. So the good news to this is we should know cosine of 45, because that is definitely on the unit circle. So cosine of 45 degrees is the square root of 2 over 2. And at this point, we're really just going to do a little bit of algebra. So the first thing that I notice is in the numerator, I'm going to need a common denominator. So I'm going to go ahead and change that 1 to a 2 over 2. So here's what I have. Now that they have a common denominator, I'm going to write that as a single fraction. So I'm going to write 2 minus the square root of 2, both over that denominator of 2. So 2 minus the square root of 2, all over that common denominator of 2. Then instead of dividing by 2, I'm going to turn that into multiplying by the reciprocal. So I'm going to multiply by a half. So it no longer looks like a complex fraction, because sometimes those might look a little bit overwhelming. So if we were to multiply straight across, numerator times numerator, and then denominator times denominator, I would get 2 minus the square root of 2 in the numerator, and then I would get a 4 in the denominator. Well, 4 is a perfect square, so we get to take out a 2. But in the numerator, we don't get to take anything out, so we're still going to have the square root of 2 minus the square root of 2. And that's going to be our final answer. Now, it doesn't necessarily look pretty. We have a radical underneath another radical, but for us, that's as far as we're going to be able to take that. So that is simplified, and that would be our final answer for sine of 22.5 degrees. All right, so let's take a look at example 2. We're wanting to find sine of 105 degrees. So first thing we need to figure out is what would you divide by 2 to get 105? Well, that would be 210. So right now, what I know is that the value for u that we're going to use is 210. Okay, so first of all, let's talk about u over 2. The 210 over 2, which is 105. What quadrant is that in? That is in quadrant 2. What do we know about sine in quadrant 2? It's positive. So we're going to deal with the positive formula. Again, this is the formula the square root of 1 minus cosine u over 2. But I'm going to replace that u with 210. So 1 minus cosine of 210 over 2. Okay, so let's think about 210, right? And if you want, you can draw yourselves a quick little unit circle. So where would 210 be? Well, let's look at the quadrants. We have 0, 90, 180, 270. Obviously, 210 is in quadrant 3. So right here, if this is 180 and this is 270, where would 210 be? It would be right there. It is 30 degrees after 180. Now, do you guys remember that ordered pair that goes there? Well, we're in quadrant 3, so both the x and the y coordinates are going to be negative. That one is negative square root of 3 over 2, comma, negative 1/2. That's the ordered pair. So again, this unit circle is coming back. We've been doing it since chapter 5. And remember, I told you guys it was really important to know it. So we want the cosine value of 210. And remember, cosine comes from your x coordinate. So we're going to use negative square root of 3 over 2. All right, well, those two negatives are going to turn into a plus sign. I need a common denominator, so I'm going to change the 1 into a 2 over 2. So I'm going to combine in the numerator those two fractions to make it a single fraction. So I have 2 plus the square root of 3 all over a denominator of 2. And now instead of dividing by 2, I'm going to turn it into multiplying by the reciprocal. So I'm going to multiply by 1/2. Well, look what's going to happen again. In the denominator, you're going to end up with a 4. That's a perfect square. 2 is going to come out, so no radical in the denominator. We're still going to have in the numerator the square root of 2 plus square root of 3. So that would be our final answer for sine of 105 degrees. Okay, so example 3. Let's take a look at it. We have cosine of 3 pi over 8. Well, let's talk about 3 pi over 8. This is a great review. So 3 pi over 8. If I want to change that into degrees, because that might be a little bit easier for us, remember to change it into degrees, you're simply going to multiply by 180 over pi. So that's going to allow the pi's to cancel out. I can also do some cross canceling because 8 and 180 are both divisible by 4. So 8 divided by 4 is 2. And 180 divided by 4 is 45. And now I'm going to multiply straight across. So 3 times 45 is 135. And in the denominator, we still have a 2. So we are looking to find cosine of 135 over 2. Good news is that it's already written in the form of a half angle. Right here, now I know that my u is going to be 135 over 2. Okay, well, let's talk about 135 over 2. If you were to take 135 and you were to divide it by 2, let's see what we would get. So we would get a 6, and then we would bring down a 1, and then we would do 7, and then 0.5. Okay, well, that's located in quadrant number 1, and everything is positive in quadrant number 1. So we're going to be dealing with positive version of this one, and this is the square root of 1 plus cosine u over 2. So this time we're using the plus sign because this is the cosine half angle formula. All right, so I'm going to replace that u with 135. So 1 plus 130 cosine of 135 over 2, and all of that is underneath our radical. So again, if you want, you can draw yourself a rough sketch of the unit circle. So we have 0, we have 90, we have 180. Where would 135 be? 135 is right here, smack dab in the center of quadrant 2. And that ordered pair is negative square root of 2 over 2, comma positive square root of 2 over 2. The x-coordinate is negative because it went to the left. The y-coordinate is positive because it went up. So here we go. We're going to have 1 plus, again, cosine, we want the x-coordinate, so we're going to be adding that negative square root of 2 over 2. Again, all of that is over 2. I'm going to go ahead and change the 1 to 2 over 2. So again, I'm going to write a single fraction, so 2 minus the square root of 2 over 2. And instead of dividing by 2, I'm going to turn that into multiplying by a half. Look what happens in the denominator again. That's going to turn into a 4. 4 is a perfect square. 2 gets to come out, but we still have the radical in the numerator. And that would be our final answer for cosine of 3 pi over 8. All right, example 4. Again, we have another radian measure. Why don't we go ahead and change that radian measure to degrees. So we're starting off with 5 pi over 12. I'm going to multiply that by 180 over pi. Right away, pi's are going to cancel out. 12 goes into 180 evenly 15 times. So when I multiply across now, I get 75 degrees. All right, well, 75 degrees, that's in quadrant 1. So we are going to be dealing with the positive radical here, but I need to change the 75 to something over 2, because again, we're using these half angle formulas. So I'm going to change that to 150 over 2, which tells me that our u that we're going to use is 150. So here we go. Let me write that formula down. Square root of 1 plus cosine of u over 2. And I'm going to plug in the 150 for the u. Okay, so 150. Well, let's see where that is. This is a great review of the unit circle. It's probably been a while since you've had to use that too much, right? So we have 0, 90, 180. Obviously 150 comes before 180, so it's in quadrant 2, right about here. It's only 30 degrees away from the 180. Does anybody remember what that ordered pair is? The x-coordinate needs to be negative, so negative square root of 3 over 2. The y-coordinate needs to be positive because it's going up, and it is a positive 1/2. Okay, so let's get back to our formula over here. Square root of 1 plus cosine of 150 degrees, that's the x-coordinate, negative square root of 3 over 2, and then all of this is over 2. Same thing's going to happen, y'all. We're going to take that 1, we're going to turn it into 2 over 2. Then we're going to rewrite that numerator as a single fraction. So we have 2 minus the square root of 3 over 2. I'm going to change the divided by 2 to multiplying by a half. Again, 2 times 2 is 4. 4 is a perfect square. We're going to take out a 2, but the numerator is still going to be under the radical. So these really aren't that hard. It's just a matter of being able to remember the formulas. Okay, so let's look at example number 5. It says simplify the expression by using a double angle formula or half angle formula. So as you are looking at letter A, now this means that we could be using either one of the formulas we learned from today, because those are the half angle formulas, or one of the formulas that we learned yesterday, those double angle formulas. So let's just real quick review those double angle formulas. So we had sine of 2x, and that was going to equal 2 times sine x times cosine x. And that was the only one for sine. Then for cosine of 2x, we learned 3 of them. The one I always remember is the first one, cosine squared x minus sine squared x. Because I can get to the other ones now. I could replace the cosine squared x with 1 minus sine squared x, which means I would end up with 1 minus 2 sine squared x. Or I could replace the sine squared x with 1 minus cosine squared x, and then I would have to distribute the 1, and that would give me 2 cosine squared x minus 1. And then lastly, we had tangent formula, and it was 2 times tangent of x over 1 minus tangent squared x. All right, so all of those are yesterday's formulas. We also have today's formulas. So what we're looking for in example 5 is, can we identify which formula was used? Well, this one right here looks an awful lot like that one right there. You see it? So what does that mean? That means that the 7 right there represents the x. So here's what that means. That means that because this is the double angle formula, I'm going to write tangent of 2x, but we know what the x is. According to this, they plugged in a 7 for the x. So they gave us this. We're going to rewrite it as this, but we're taking the x out and we're putting the 7 in. And 2 times 7 is 14. And this is not a number that we know from the unit circle. And that's it. They just want us to simplify the expression, and that's as far as we can take that one. All right, so let's look at this one. This one doesn't look like any of the ones that we learned yesterday, right? And you're right, it's not. It looks like one of the ones from today that we haven't used yet. So let's go back to the notes. See it? Which one is it? It's the tangent one, right? So according to this 48 theta is the u. So this is the tangent of u over 2 formula, but we know that the u is 48 theta. So we're taking u out and we're plugging in 48 theta. And 48 theta divided by 2 is 24 theta. And that is as far as you can take that problem. All right. We are getting close to being done, y'all. 2 more examples to go. Example 6. We want to find tangent of u over 2 if sine of u is 2/5 and u is in quadrant 2. Okay, so you know me, I like pictures. So u is in quadrant 2, so I'm going to draw my triangle. Here's angle u in quadrant 2. All right, and it says that sine of u is 2 over 5. Well, remember, sine means opposite over hypotenuse. So opposite is 2, hypotenuse is 5, and we can use these numbers to find the missing leg. So 2 squared plus my missing side squared equals 5 squared. So I have 4 plus x squared equals 25. I'm going to subtract the 4 over, which gives me now a 21. I'm going to square root both sides. When I square root both sides, I always include plus or minus, but let's look at where our triangle is. If we are in quadrant 2 and we've started from the origin and gone to the left, what kind of number will that be? That's going to be a negative number. So I'm going to have negative square root of 21. Hopefully that makes sense. Remember, if you're in quadrant 2, your x coordinates are going to be negative, and that's what's going on right there. Okay, so we're going to be using one of the tangent half angle formulas that we learned about today. There are 2, and we get to pick one. So I'm just going to go with the sine u over 1 plus cosine u. It doesn't really matter which one you go with. I'm just going with that. Okay, so let's see what we have. Well, we already know what sine u is. It's 2/5. Then we're going to do 1 plus cosine of u. So again, we're going to go back to our picture and we're going to find cosine. Remember, cosine is adjacent over hypotenuse. So adjacent is negative square root of 21 and hypotenuse is 5. Okay, looking pretty good. Now in the denominator, if I want to add those together, I need a common denominator. So I'm going to turn that 1 into a 5 over 5. So I have 2/5 divided by, now I'm going to put this as a single fraction, 5 minus the square root of 21 over 5. How do we divide fractions? Easy. We turn it into multiplying by the reciprocal. So that second fraction turns into 5 over 5 minus the square root of 21. All right, good news. 5's cancel out. Bad news. We still have a radical in the bottom. Ooh, this is a good algebra review. How do you get rid of the radical? Well, you have to multiply by the conjugate. You guys remember conjugate? Conjugate is where you take this binomial and you multiply it by itself, but you change the sign in the middle. So instead of a minus sign, we're going to turn that into a plus sign. And whatever you do to the denominator, you have to do the same thing to the numerator. So we're multiplying both the top and the bottom by 5 plus the square root of 21. All right, so in the top, for just a moment, I'm not going to worry about distributing that because there's a possibility maybe later that I might be able to reduce. So I'm going to ignore it for a minute. But in the denominator, I got a FOIL. So let's talk about first. 5 times 5, that's 25. Outer would be a positive 5 on the square root of 21. Inner is a negative 5 on the square root of 21. Herein lies why you multiply by the reciprocal, because those two things are going to cancel each other out. We're getting rid of the radical. Then for last, negative square root of 21 times the square root of 21 is a negative 21. So now let's see what we have. In the numerator, we have 2 onto 5 plus the square root of 21 all over 25 minus 21, which is 4. Here's why I did not distribute that 2 yet, because sometimes you can reduce rather than having to distribute and then take it back out. So the 2 over 4 reduces to 1 over 2, so that our final answer is 5 plus the square root of 21 all over 2. So that's going to be our answer for tangent of u over 2. All right, last example. We're going to find the half angle formula of sine, cosine, and tangent. So we're going to do all 3 of them. It says if cosecant of x is 3. Well, what does that really mean? Cosecant is the reciprocal of sine. So this means that sine of x is 1/3. All right. Now, where would sine be positive? Sine would be positive in quadrants 1 or 2. But then the next thing tells us that x is going to be in between 90 and 180. So that tells me that we're going to be in quadrant 2. So I'm going to be drawing another picture. We're going to have a triangle in quadrant 2. So it says sine of x is 1/3. That's what we wrote down right there. So I'm going to put angle x right here. Sine is opposite over hypotenuse. So the opposite is 1. The hypotenuse is 3. We're going to have to find the missing side. So 1 squared plus my missing side squared equals 3 squared. 1 squared is just a 1. 3 squared is a 9. I'm going to subtract the 1, which leaves me with 8. Then we're going to square root both sides. Well, we're in quadrant 2. Again, like we were earlier, what's going to happen to this value? It's going to be the negative and not the positive, because when you start at the origin and move to the left on the x-axis, that's a negative value. So this is the square root of 8, but remember you can simplify that because 8 breaks down into 2 times 2 times 2. So we're going to have 2 onto the square root of 2, but it is negative. So we now have a picture. So let's go over and let's start with sine. Okay, so our formula. Now let's talk for a minute, because remember we said that whether or not you use plus or minus is going to determine where x over 2 is. Well, we know that x is in quadrant 2. We don't know the exact number, we just know it's some number in quadrant 2. But if you take any number in quadrant 2 and you chop it in half, what quadrant would that put you in? And if you don't know this answer, try it. Try like if you had a 92, or if you had a 116, or if you had a 178. If you took all of those numbers and you chopped it in half, every single one of those numbers would land you in quadrant 1. And so because it would land us in quadrant 1, we're going to be dealing with the positive radicals for all of these. Okay, so my formula here is I have the square root of 1 minus cosine of x. I'm not using u this time because we have an x there, over 2. Okay, so now we got to go back to the picture. So according to our picture, cosine of x. Cosine would be adjacent over hypotenuse, so I'm going to have negative square root of 2. I'm writing it wrong and I'm saying it wrong. Let me start that over. Negative 2 onto the square root of 2 over 3. There's our cosine measurement right there, because we did adjacent over hypotenuse. Now, one thing I can go ahead and do is realize that those are going to turn into a plus sign. Secondly, I'm going to go ahead and change that 1 so that it is a 3 over 3. So here's what I have. I have 3 plus 2 onto the square root of 2 over 3. And then instead of dividing by 2, I'm going to change it to multiplying by the reciprocal. So I'm going to multiply by a half. Well, let's look and see what happens, because guess what? 3 times 2 is 6. 6 is not a perfect square, so we don't get to take anything out. Now, we always say that you can't have a radical in the denominator, but this is one of the few instances in pre-cal where we're going to be okay with you leaving this as such. So instead of having to rationalize, because that would look so much messier, we are just going to leave it just like that. All right, now let's move on to cosine of x over 2. Again, we're going to have positive radical because x over 2 would be in quadrant 1. If x is quadrant 2, then this would have to be quadrant 1. And the only thing that changes is we're going to have a plus sign right there instead of a minus sign. And you may already kind of guess what's going to happen, but I'm going to walk through the steps. So I'm going to have 1 plus cosine of x isn't changing. It's still negative 2 on the square root of 2 over 3. Again, I'm going to change that 1 to 3 over 3. So I have square root of 3 minus 2 on the square root of 2 over 3. And instead of dividing by 2, I'm going to change it to multiplying by a half. And guess what? Our answer looks almost identical to what we just had, except we have a minus sign instead of a plus sign. So we have our sine half angle formula done. We have our cosine half angle formula done. Now, one thing I told you at the beginning of the lesson is if you already have those two, you can use those two answers to come up with the next one. But I would say with this particular problem, that's probably not the way to go, because you have a lot of radicals and that would look super confusing. So we are going to use one of the other tangent formulas. Now, earlier I used the one that was sine u over 1 plus cosine u. Just to be fair, I'm going to use the other one this time. So this one is going to be 1 minus cosine u, but instead of u, we're using x over sine u, but again, instead of u, we're using x. So I'm using the other one because I used the other one last time. So here we go. 1 minus cosine x. Well, we've been doing the same thing for a while. So still at negative square root of 2 over 2. Sorry, negative square root of 2. Good gracious, I'm having a hard time. Negative 2 square root of 2 over 3. Man. And then we're going to do sine of x, which we already knew from right back up here, or you could go back to your picture and figure that out, and that is a 1/3. Okay, well, these two negatives are going to turn into a positive. The 1, I'm going to turn it into a 3 over 3. So I'm going to start by writing this numerator as a single fraction. So I have 3 plus 2 onto the square root of 2 over 3. And then I have divided by 1/3. Well, I'm going to change that into multiplying by the reciprocal. So that's going to turn it into 3 over 1. Guess what? 3's cancel out. And you have a pretty decent answer for this one. There we go. 3 plus 2 on the square root of 2. Okay, so lots of formulas. I know it is a lot. The best thing I can say is as you are doing problems, write the formulas down first, because the more you write them down, the faster you will learn them. And tomorrow we will be having a Zoom session at 9:15. I would like everybody to attend. I'll put the link up later in RenWeb, and we're going to be doing some preparation for Monday's quiz on 7.2 and 7.3. So I will finally get to see you with my eyes tomorrow on Zoom. It's been so long, I miss all of you, and good luck with your homework tonight. Let me know if you need help. Shoot me an email, and I will answer accordingly. See you tomorrow.